All right, so today we're going to talk about Newton's laws of motion and forces, three of the most important laws in nature. So, first, just to kind of show you where we've been and where we're going, before this unit, we talked about kinematics or 2D motion and calculus, and we didn't really mention a lot about calculus, but really we talked about Newton was developing kinematics and calculus kind of at the same time. So, it's his last unit. We used Newton's equations of motion to predict an object's position, velocity, and acceleration at any moment in time. So we did a lot of problems where they'd give us like how fast an object was moving, and then they told us how long it was going to move for, and then we could figure out different things about that object, where it would be located in time and space. But the one thing we never said is why. So why was that object even moving in the first place? So basically, what we just studied was called kinematics, and now we're moving on to something called dynamics, which is basically Newton's laws of motion and forces. So dynamics says now Newton wants to mathematically describe why an object moves or doesn't move in the first place. So before we could calculate in space and time where an object is, how fast it's going, what's its acceleration, and now we want to talk about why it's doing what it's doing. So before we get to Sir Isaac Newton, we're going to start with this gentleman here, Galileo. So it says Galileo's ideas of motion, and he lived from 1564 until 1642. A couple of things before we get too far into Galileo. He was a scientist and not a philosopher. So sometimes people talk about people who were doing thought experiments back in the day, but Galileo was actually one of the first people to actually do what we would consider scientific experiments. So basically, he was a physicist and he's an astronomer. And before I kind of talk about him here, maybe just think back maybe what you know about Galileo or what you have heard in the past. So go ahead and hit pause and just think about any major discoveries or things that Galileo is responsible for. The ones that I want to include in this lesson today, major discoveries, he built a telescope that was, I think it was like 32 times more powerful than any other telescope that had been invented before. So what he started doing is he was making observations of our solar system, and he was one of the first scientists to say that, hey, the Earth actually orbits the sun. So before that, the teaching of the time was switched. I'm not going to say it the wrong way because I don't want to teach anybody the reversed way, but the Earth goes around the sun. And so during his day, he started teaching that to people because he had students. And then the people in charge at the time said, no, that's not true. They called him a heretic. They found him guilty of false teachings, and he actually was sentenced to house arrest. It was kind of like the first example of house arrest, where basically he had to stay at his home and then had, I believe, guards outside his door. So Galileo, through observations, scientific observations, said that, no, hey, the Earth orbits the sun. And before Galileo, there was another person named Copernicus who also said that as well. I put this picture of the Leaning Tower of Pisa in here. I've read a couple of things about Galileo and seen quite a few documentaries. And kind of the story goes is that he would actually climb the stairs, go up to the top of the Leaning Tower of Pisa, and then he'd drop different things off the tower to see how they accelerated down. And one of his major discoveries was is that all things fall at the same acceleration, the same rate down. And so very influential scientific mind of the time. Where we're going to pick up Galileo today is with this little thought experiment he did, and it's not too controversial. This is the least controversial thing probably he would say, right? But he pictured, say you had this ball over here, and over here you can see, I'm just going to highlight it kind of in red. He said if you had a ball that was on an incline, and you let it go, and the incline's frictionless, the ball is going to roll down, and then it's going to roll up. And he said it should roll up to the same height on the other side. And he thought to himself, okay, well, if I had this ball right here, and now the incline's at a different angle, he said, I don't think it matters the angle. I think that ball should roll up to the same height over here. And then he said, well, hey, say I have this ball again on this incline, but now instead of there being another incline over here, it's just a flat surface. What would happen to that ball? And he said his conclusion would be is that a ball that's rolling will just keep rolling until acted upon. And that doesn't seem too controversial. It kind of makes sense to us now. But back in the day, it was a little tougher to think about because there's friction there. And he was saying, hey, if there's no friction, that ball is just going to keep going until something acts on it. So Galileo has this groundbreaking ideas about the solar system, about the acceleration from gravity, and then about objects moving. And then he dies in 1642. And then a little trivia question here. What famous scientist is born in the same year that Galileo dies? And if you said Sir Isaac Newton, you would be correct. So Galileo dies in 1642, and then that same year Isaac Newton's born. So just a little quick biography on Newton. He invented calculus, which we've talked about before, and kinematics, and then his 3 laws of motion. And it's basically agreed upon that he did that before the age of 26. So he was a pretty young guy coming up with this groundbreaking physics ideas and concepts in math. Very smart individual. He studied color and optics, sometimes too intensely. I've read stories about him staring at the sun for hours at a time and how his vision was very poor. So he was the first person to propose a theory saying that the white light is all of the colors Roy G. Biv mixed together. So he was the one who said that white light, if you pass it through a prism, will break up into Roy G. Biv. And that's actually how Newton came up with a new telescope, is using that idea. After 26, he stopped studying science so much and started studying religion a little bit. And then later in his life, he came back to studying science. And then probably one of the more tragic things about his life is that he lived during the plague. And so he was actually at Cambridge University in England, basically getting his undergraduate degree. And due to the plague spreading throughout Europe, school got shut down for 2 years, and he went and lived on his family's farm in quarantine for 2 years. And he was there on his family farm for, I believe it was close to 2 years. And that's during those 2 years he invents that stuff right there, the calculus, kinematics, and the 3 laws of motion. And then he comes back to college, and people are like, Newton, what were you working on while you were away? And he is a pretty secretive guy, and he didn't tell people right away that he had invented this new form of math and this new way to describe motion. So Isaac Newton, very interesting individual. Where we're going to pick him up here today is Newton's first law, otherwise known as the law of inertia. And so I'll go ahead and read this, and just feel free to jot this into your notes. It says, an object at rest stays at rest. An object in motion tends to stay in motion with constant velocity. Both objects will keep doing what they are doing until acted upon by an outside force. And there's a good chance you've heard this before, and I always tell my students, I think this is probably the most important concept that I teach my students throughout the entire year, because if you're an athlete, if you're involved in any kind of activities or clubs where you're playing sports, Newton's first law is all over the place. Instead of calling it the first law, it's also known as the law of inertia. And another way to say it is things keep doing what they are already doing. So if an object's moving, it has a tendency to want to keep moving. If an object's at rest, it wants to kind of stay at rest. And some of you out there might be thinking, well, this sounds really familiar. I've heard this before. And if we go back, I'm not going to go back, I have to click through all this. If we go back, basically sounds really familiar to Galileo's experiment here, where he had a ball, and he said a ball will keep rolling until acted upon. So I know it seems like kind of an original idea that Newton has, but really he's based it on Galileo. So I kind of feel like Newton maybe said, hey, that Galileo's idea is pretty good. I'm going to call that my first law. So he definitely studied Galileo, right? So we'll flip back over here to Newton. So this is the first law. Every once in a while, I'll have a student say this word incorrectly. Inertia is the right way to say it. Inertia is a property of matter. Copyright Bill Nye. But I had a student one time who called it inertia. I thought that was funny. They came up to me at Valley Fair and said, Mr. Laurent, how much inertia does that roller coaster have? And I just laughed. All right, so things we have to know about Newton. This is Newton when he was basically in his college days there. So he's at Cambridge University. He comes up with this term inertia, and it's really important. It says the more mass something has, the more it wants to keep doing what it already is doing. So the term mass and inertia kind of can be interchanged with each other. So if something has more mass, then we say, or he says, it has this property called inertia. And all inertia means it has a willingness to keep doing what it's already doing. And if you have more mass, then you're going to have more of a willingness to keep doing what you're doing. A good example of this law in action, there's a whole bunch of them. The one that kind of stands out to me is if I'm driving in my car and you're cruising along and you're an object in motion and you want to stay in motion. And sometimes we forget about this, but everything in our car is also an object in motion. So, for example, I know one time I set a bag of groceries on my passenger seat after I went to Target, and I'm cruising along, and the car in front of me stops, and I slammed on my brakes. Well, everything that's attached to the car, so I'm seat belted in, I'm holding onto the wheel, I slow down with my car, but that bag of groceries is an object in motion, so it wants to keep going forward. I one time I had a student who told me that whenever they get Chipotle, they always buckle in their Chipotle so it stays attached to the car. I feel bad. I probably shouldn't share this story, but I'll share it. When my dog Lucy was a puppy, we used to take her to the Alameda Dog Park in Burnsville, and it was a Sunday afternoon one time, and we would bring her there, and I brought her there on Sunday by myself one time, and Lucy was in the back seat behind me, and Lucy's was not buckled up because she's a dog, and I was kind of cruising home fast because I wanted to get to 12 o'clock was the Vikings game, and I wanted to get home, and it was like 11:52, and I'm cruising. I guess it'd be up Lac Levon, kind of by the Walgreens and the Devani's over there, and I see the light turn yellow, so I accelerate, wanting to go forward, but then the car in front of me all of a sudden slams on their brakes, so then I have to slam on my brakes, and then poor Lucy is an object in motion, and I slammed on my brakes, and then I heard, and then Lucy's body hit the back of my chair. So Lucy was pretty upset with me, but she was okay. But I tried to explain Newton's first law to her, and she was upset. So that's why you want to make sure you always buckle up. All right, we're going to look at a couple examples. They're two of my favorite ones. Example one is pulling out a tablecloth, and then I'll show you a video of that. And then example number two is the pen and a Coke bottle example.